Welcome back to Algebra 2. This is 1.5, Part 2. We had too long of video to be able to put that in one section, so we are still working on solving basic equations, and the next kind of rather unusual equation we might have would be the absolute value equation. Let's say you were to ask to solve that. Well, remember what absolute value is talking about. We're talking about a distance from 0 on the number line, a distance of 3 from 0 on the number line. So we could either have it equal to 3 or equal to a distance of 3 on the other side of the 0. Okay. So this would be a negative 3. So you can switch this because of this definition of distance on the number line. You can switch this to really two equations, either x minus 3 or x minus 2 equals 3 or x minus 2 equals negative 3. And just like we had before when we were doing two binomials multiplied together, we are going to expect two solutions with an absolute value. Solving this by adding 2, we get 5, or solving this one by adding 2, we get negative 3 plus 2, or negative 1. Two solutions. Okay. So we would write our solution as negative 1, 5. Let's check both of those, make sure before we move on. If we plug in negative 1 to our original equation, we get negative 1 minus 2, or negative 3. Take the absolute value of that, and that is 3. 3 equals 3. That one works. Take 5. We get 5 minus 2, or 3. The absolute value of a positive number is the counter, the 3 itself, and 3 does equal 3. So both of those solutions work. So, reminding you of certain ideas. Now, we have two things we have to be aware of in algebra, and one thing is talking about extra solutions or extraneous solutions where we're doing our algebra correctly, but we're getting a solution that should not have been a solution to the original equation. So we need to be aware of extraneous solutions, and we also need to be aware of what we would call lost solutions. Let's take something like x minus 2 equals 0. And normally I would just add 2 to both sides and I'd say x equals 2. And that would be my solution. That would be perfectly correct. But what if, for some reason, the equation is more complicated than this, and I'm not thinking quite clearly, and I decide, well, the first thing I want to do is multiply both sides by x. So I would get x times x minus 2 equals 0 times x. I think I can multiply both sides by 2, or by x, and then notice, though, when I expand this out, there's several ways I could solve this, but I could expand this and get x squared minus 2x equals 0. And I could, let's say I could say x squared equals 2x. I'm kind of getting myself stuck into something I didn't really want to show you here. Hang on. Okay, backing up just a little bit, let's say we're going to do it this way. This would be x times x minus 2 equals 0. And notice that I have, just as I did above when I had an expression times an expression equals 0, and I knew that either this would have to equal 0 or this would have to equal 0. So here I've got two multipliers. This equals 0, or x minus 2 equals 0, or x equals 2. Notice here I had two solutions, and here I only had one solution, which is correct. Well, the original equation was this. Plug both your solutions back into the original. Does 0 minus 2 equal 0? No. So this is an invalid. The first one, the first solution set, is invalid. The x equals 0. The x equals 2 is the only valid solution set. So two morals of this story. One, you always have to go back and check your answers. Two, you want to beware of a couple, what we would call valid algebraic approaches that can cause issues for you. One is beware when you multiply by a variable or an expression with a variable. I could have also run into trouble if I tried to, for instance, multiply both sides of the equation by an expression like x minus 2, variable or expression with a variable. So every time you do that, sometimes you'll want to do that, but every time you do it, you must stop and check your answers, making sure they're all valid before you conclude your solution set. Expression with a variable. The second area you can run into trouble is by missing out or losing part of your solution. Let's say I had an original equation that said x squared equals 4x. I might want to divide both sides by x, and I would get x equals 4, and there's my only solution set. But you might remember from your Algebra 1 that anytime you have a term with a second degree, I'm expecting two answers. And in fact, there's going to be a better way to solve this. If I solve this by taking this to the left, I would go x squared minus 4x equals 0, factor. And then I have two answers, two solutions, as we showed before, 0 and 4. Are both of these correct? Well, you have to go back to the original equation. If I plug in 0, I'm going to get 0 equals 0. That is a true solution. And if I plug in 4, I'm going to get 16 on the left equals 16 on the right. Both solutions are correct, but if I did this method of dividing both sides by a variable or an expression with a variable, I lost one of my solutions. So fundamentally, always check your answers. A hint would be if you have a second degree equation, you're going to be looking for two solutions. If you have a third degree, you'll be looking for three solutions, etc., etc. Always check your answers. Be very careful when you're either multiplying or dividing by a variable. Know that you must stop and analyze that more carefully. Now, there is a reason for that. Actually, maybe I'll just go into that later. I decided to go ahead and finish my thought, and that is I had x squared equals 4x. I am dividing by x on both sides so that I could get x equals 4. But remember that I cannot divide by a 0. So I have thrown out one of my solutions, x. I am assuming here when I do this step that I am assuming that x cannot equal 0. But in fact, 0 was one of the values or solutions. And so I've made an assumption right here. And that's why I lost this as one of my solutions. So that might be a little complicated for you, but the bottom line is multiply by a variable, divide by a variable, or an expression with a variable. You have to be careful. You have to check what you're doing, and this will become more real, and you'll get more practice identifying this as time goes on.